Okay folks, here's part 2 of our shortest path between the fly and the spider. I called it a fly and a spider. If we have to look at the shortest path, we know the shortest path between 2 points is the line segment that connects those 2 points. So what I have done here is I have formed a replica of the room. This is the floor space, this is the wall on which the spider is, and that is the wall on which the fly is sitting. But you'll see I've got 2 versions of that wall. I've got the wall because remember AC is going to connect with this AC over here. So it's literally dropping the back wall flat, dropping this wall flat, and then joining the line from the spider to the fly. Now on this path it means the spider is going to walk to point T on the corner line, and then from T walks right to the fly. So if I had to draw it here, it will go somewhere up there and then go straight to where the fly is on the other wall. Now folks, you've seen what I've done here. How did I construct this? In the same way as what I constructed the previous. Remember I said the height of the room is 3 meters high. The floor is, I think this was 4 and this was 8, and this height was 3 over there. We can check that quickly by just saying measure the length. Okay, that is definitely the 3 meters, the height of the wall. This length here I think was 4 meters, yes, definitely. And then this length over here is, measure the length, is 8 meters. So this is an 8 by 4 floor by 3 meters high. The dimensions doesn't matter that much. The fact is that I need my fly, from my fly to my spider, I need a straight line. Okay, I need a line segment. There I said the swear word, straight line. Okay, all lines are straight, for goodness sake. What's wrong with my intelligence today? Okay, so there we go. We have that line segment. It intersects the side at AC. The alternative, you'll see here, those 2 distances are the same. So the alternative would be to walk to the floor to a point. So if I construct that intersection to that point, walk across the floor to the point where it intersects over there, and then from there walk to the fly. So there's 2 paths, and the paths are equidistant. Now why are they equidistant? Let's just see what I've done here. From the fly to point P is there to the ceiling line. So there to the ceiling line to R, those 2 must more or less be the same. And the same over here. Now I found it very difficult to do that. So from this to the corner here must be equal from where the fly is there to the corner there. So I've sort of tried, if I take these and I make them, or only go into the hundreds, let's just say properties as in the hundreds, then I get 1.11, and here I think I'll get 1.1. Properties in the hundreds, let's just go there, will give me 1.10. Now I won't get closer than what I have over there. I've tried to do it with 100,000s. So just, you must show in your work, show the 100,000s. Don't do what I'm doing now. So those 2 look equal, but we know they're not. Those 2 are damn close. They're 100th of a centimeter apart. Okay, so now I can move my spider anywhere. I can start moving the spider around. I'm going to keep those points the same, and let's see how this changes. Okay, so if the spider was over there on the wall, it will be quicker for the spider to go across the floor to the fly than to go to the wall and walk across the wall. If the spider was, if the spider was in this corner, we can see the option along the wall is the closest from our measurements over there. Okay, so it's really got to do with where is this spider to try and see. Let me put those close to each other so we can see how they change. If the spider is close to the floor, it seemed to be that the floor, go to the floor, walk across the floor, walk onto the wall is the shortest path. If it is closer to the ceiling, there, if the spider was there, let's just move it horizontally and see what happens here. If it was more or less where this is now too far gone. So if I move it up a bit as well, I'm trying to get these two to be the same so that it doesn't matter which road the spider chooses or the journey the spider wants to walk. Now you can see there's a million or 100th difference between where the spider has to go. There, it's closer. There we go. There we go. Perfect. So if the spider was there, the distance, whether it walks across the floor or whether it walks directly across to past this corner and stays on the walls, the distances appear to be equal. Now folks, if I make this hundreds of thousands, we'll see that there's definitely still a difference there. So I'm just keeping it here now for argument's sake, but when you present your work in your portfolio, please go for the hundreds of thousands so we can see the closest it is. Now remember, when you do your portfolio work as well, you've got to save these files in electronic format. Save them as Sketchpad. So file, save as, and make sure it's saved as a Sketchpad file here. Give it a name. Okay, I'm going to call this honors or spider fly number 3. So spider fly sketch number 3. And I save it, and I save it in my honors form or folder, and it's ready for examination. Okay, so you've got to do this type of thing. How did I construct these two there? They're identical. I told this point I knew was 3. So I knew the length of this room is 8. So I clicked on A and I said transform by translating it 8 units 90 degree upwards, and it got to that point over there. Okay, and then that one 3 and this one. Now to get this side of the wall here, I had to tell B to transform or translate, but instead of saying 90 degrees, which would take it to D, or to, not to D, to another point up there, which is not what I want. I want that point B to be 3 units, but I can't say 180 because then it constructs it inwards. So I had to say 360, then it constructed it to the point B prime over there. Okay, so folks, please get your work ready. And now you've got to present an argument here of how do you measure the shortest distance from the fly to the spider. How must the fly walk? Okay, and present the argument for the particular room that you are constructing. I hope that that helped you in your investigation of the spider and the insect problem. Okay, folks, carry on working.